right, go ahead.
Hello, everybody. My name is Ernestus. I'm from company Intelligent Beam Solution, and you're welcome on this session where we'll talk about how you can save energy and money with building performance analysis. I speaking in English because it's international session. Let's say there are online participants. So, but anyway, if there will be questions, just interrupt us and maybe we'll translate something if you are interested, okay? So, shortly about this event, about this seminar. Change. Oh, yeah, okay.
That's fine.
Shortly about our company. Intelligent Beam Solution itself, the name actually can say a lot. We are a beam consultancy company, and we think about different technologies, specialized technologies for different building design parts. And the key is how to cooperate between each other and how to reuse work. For example, structure engineers, you have to reuse work of architects, or MEP engineers, mechanical, electrical, piping engineers, you have to reuse what was done by architects or structure engineers. So we are speaking about Open Beam Ideas. It's Building Smart International Alliance, which care about cooperation standards, international standards, which, by the way, now it's standard in European Union also. So our areas, it's design. We can name it 3D, but BEAM it's not 3D. BEAM it's first of all the process and information. It's not the view. So structural, architects, mechanical, electrical, piping, and also, of course, we should care about what next. Next is construction and facility management, building services. So what is BEAM about? It's actually from the beginning, from conceptual design through the maintenance, all information. So just some different softwares where we have partnership. And Integrated Environment Solution Company is one of them, which start from the beginning and going through all the project. And we will talk about that. So it's just very shortly about our company. You can just find information intelligentibeamsolution.com. And let's come back to building performance. So main issues, what we see in our countries, and probably not only in our countries. So buildings. Our buildings consume 25% of all drinking water. It's a huge amount. Our buildings consume 40% of all energy. Buildings, 40% of energy. And our buildings consume 55 woods, forests. So it's huge impact to our earth resources. Yeah. And another sad story, our buildings produce 40% construction waste and carbon emission. 40% of all carbon emission. So we just think that, okay, buildings is just buildings, and our, let's say, industrial part produce a lot of bad things, but it's wrong. This is statistic. Yeah, so buildings is important to our environment. So, and another note, what I would like to say, and this is also main issue, not only ecological things, but it's not only ecology. It's money. And I know there are some property developers, and money, it's also quite important things. And there are always questions how to save money. how to be more efficient, how to achieve the best building performance. So today we will talk about let's say case studies. We will talk about results. We will talk about how what is effect for ecology, but also and for money. Okay, there are people from different business paths and designers and engineers and property developers, also from educational academical institutions. So in a way, we all should think about final customer of the building. All we should think about final customer of the building. And another issue we found, and we discussed that a lot with different people, with people from Gediminas Technical University and other institutions, it's calculated building performance. For example, class A plus or B or C. So calculated building performance differ from actual. This is very important issue. Someone declared that this is class A, but after measuring that, we realize that it's not true. So this is the issue, and this is a big issue. Customer buying products, it means building, which is actually not what is declared. Okay? So our company always care about why it's happening. And we have a quite interesting discussion, and I think we should raise this discussion on more high level, on public level, why it's happening, why reality so far from calculated results. And we defined main two reasons or main two areas for that. It's calculation methodology, not includes all factors, and it's static, mainly static. And of course, another group of causes of this difference is changes in construction. It means some companies would like to save own money and make changes, not according project. Okay, so but today we will not go so deep to those issues, but we should be clear that there are differences, and we should be clear that we should do something in another way in order to eliminate these differences. Okay. Building performance analysis. I think that building performance analysis is one of the most important tasks in the project, in early stage of the project. Why? Because building performance analysis should answer your question, what should be done and why? It's actually argumentation, why we made one or another decision about architecture, about materials, about ventilation or heating system, and so on. So actually we are talking about argumentation, and we're talking about, let's say, analyzing different versions at the beginning, early stage beginning, in order to find the best. In our country's practice, you know that we always it doesn't matter which stage, we're always searching new and new options, we're always optimizing the solution, and it causes a lot of changes in the project, in technical project stage, in construction project stage, and it's not efficient way. And building performance analysis should start on conceptual project. Let's name it. Okay, in our country, in Lithuania, we have not so strong this phase. The name of this phase is proposal. So the name itself saying that, okay, it's something wrong. Nothing will be done well if it's proposal. Of course, proposals for free. So I think in order to be more efficient, we should learn from our more developed countries, from Nordics, from West countries, where conceptual project, it's separate project, it's quite serious project, and I think it's most valuable project for customer. And only then, when it's clear decision what and why we should do, only then we should go to technical project and construction projects. It will help to define and argument solutions. It will help, will be much more efficient in technical project. It will cause less rewards for everyone. As a result, building performance analysis on the early stage should help you to answer main conceptual question. What kind of building should be? What kind of heating or ventilation should be, and why? The question why should be calculated and proved. Okay? Building performance and cost point of view also, we should not forget that, because for customer it's main let's say task to calculate not only comfort level of the building, but also and performance cost, maintenance cost. Okay, so cost, it's always here. So in conceptual analysis, of course, we should analyze and building and maintenance cost questions, cost point of view. Yeah, and then technical project goes much more efficient for everyone, by the way. And today our partner in integrated environment solution company, green design expert Michel from ES will present how you can save energy. It's for ecological reason, and money is for business reason with building performance analysis. Welcome.
Okay, so let me just make sure everything seems to be going online. And I'll just introduce myself. My name is Michelle Farrell. I work with integrated environmental solutions. My job is mainly to work all throughout Europe. So I work a lot in Scandinavia and France, Italy, basically many countries that are finding different ways to become part of the green story. And most places it is going to come down to money. So what we're going to look at today is kind of steps. And first, you're not going to see our software. First, we're going to talk about how we use our software to create solutions. So the first part is case studies. So these are projects completed by our company. We have building physics engineers, mechanical engineers, architects, and how we can change the story from being, yeah, everyone should be green. We all want to hear that. But it is going to come down to usually two reasons: government regulations that require you to do it, or you can prove you can save money. And that is what you can do with this. Then we're going to go into the actual software itself and how you would go through this process. So we'll probably go, I think, about an hour to start with, and then we'll take a break. And then we can also look at green rating systems. So whether Lithuania and the different Baltic countries decide to start your own system, or you go with BREEAM or LEED or one of the existing systems that are out there, they're all different twists on saying how do we prove that a building is ecological, but also how do we prove that that's good for the consumer, or why should the building manager do it? And it's quite a big project in many countries. Everyone's at their new stage of development now. And I, of course, am American, so I started off working in the United States doing this, where LEED is the #1 software there. But there, of course, it's coming down to money, perhaps more than in other areas where, like Scandinavia, it comes down to the government regulation. So looking at the background of IES, we were founded in 1994. We're actually headquartered in Glasgow, Scotland. We're the #1 software for building analysis in the UK, in Australia. We're a very big market player all through North America, many countries in Europe, like France, for example. We're one of the most used softwares there. An interesting thing about France, they also have a building label system. And people, because it doesn't give you an accurate picture of what the building will consume, they're doing another type of analysis after. We also have a very large software development team. And if I'm speaking too fast, please tell me stop it, and I will. And we're continually improving the software based on user input. That means we have specific tools for different areas of the world. So like we have tools for Australia, special tools for India, for the systems used throughout Europe, for the systems used in the UK and also in the United States. We also have a worldwide partnership with Google and Autodesk, and we also collaborate with like ArchiCAD as well and other software manufacturers to make sure that you can import that, because that's really going to be your key when you're starting early stage analysis, is to be able to get your 3D model in as early as possible for analysis. We're used in over 140 countries. We have a few clients here, not a lot, but we're rapidly expanding in North America, Europe, and the Middle East. And you can see some of our clients, such as Sweco, Skanska, Arup, AECOM, many who might have some offices here. And those are the people who are using us at this time. We're also used by Ramble and many of the companies that may have a few offices here and do international work. So the idea of our software, first I'm going to focus on what is a very kind of basic overview, like why do you do this? Well, the idea first is that you have a single integrated building performance model. So you're going to import a 3D model, or you're going to build a 3D model in our software. That model is going to represent what will be built in the future, easy enough, and then you're going to do different studies on it, and you're going to get as detailed as possible with it. I mean, of course, how much your budget's going to allow for that, what type of details you want to add, what type of analysis you want to do. You may also want to do something like BREEAM UK or different systems around Europe to try to prove an energy label. You might want to look at solar studies or lighting and daylighting. But really your company will decide what pieces you put together. So when it does come down to how does this save you and your clients money, one of the first ways we look at the software is comparing green materials. If you're a building owner, one of the biggest things now is people coming to you, we have a new insulation, we have new windows. These windows are going to save you so much energy per year. Well, you might have 4 manufacturers coming to you, and you want to say which of these products is really going to make the biggest difference in my building. And that's what this type of analysis can do, is you can test, let's say, 3 types of window manufacturers against each other and pick out the one for the money that's going to save the amount of energy you want. Also understand where the best investments are for improving existing buildings. So if you have an existing building, you've done something like a site survey and you understand how much it's consuming, you know you want to do something to improve it. In many cases, the government will invest in some of the governmental buildings. You can go in and start to test different things, like would it be better if we upgraded the HVAC system or dealt with infiltration through the roof or fixed the external windows, where to put the money first for the biggest, I guess, drops in energy use. There's an interesting case in the UK where companies, small engineering firms, are going to owners of existing buildings and saying, we will do an energy analysis for you for free, but you're going to have to give us a percentage of your energy savings per year. So it's a way of small engineering firms getting themselves in the market, making some money and saying, we'll do it free for you first, but you give us some of that savings. It's a great way for a company who may not have invested in this type of thing to get some money back and also pay someone maybe for 5 or 10-year contract a percentage of that energy savings. And if you look at the existing building stock in many countries, whether it's warehouses or very basic ones, it's very realistic that you could save a ton of energy for them. Also, understanding how many years it will take to earn back money from your green investments. So let's say someone comes to you with solar panels or better windows or something like this. Your client is going to want to understand, I want a payback period for this. If these solar panels are 20 years, maybe that's something I'm not interested in. So it could be that you're defining, here's the items that you can invest in, here's when you're going to earn your money back from that initial investment. And that's a lot of what our company does through these consulting projects that you'll see. And also how you can use free sources like daylighting and natural ventilation to reduce loads. So this is going to be something that's often ignored when you're just doing straight up heating and cooling loads for buildings. So understanding how if we had daylight sensors in a space, how turning off the electrical lights, how much energy we could save, or if we were able to open the windows instead of just calculating everything shut all the time. So this small, and of course this type of simulation is going to cost money, okay? It's going to cost money for your firm to do the work, but it can save tens of thousands of energy savings later. And we'll get into the case studies in a second, but this is basically the message we're going over. And also one thing we found in other markets, and all of these companies, if you're like a property developer that rents apartments, if you look up any of the studies for LEED or BREEAM or DGNB, any of these buildings that have a green certification level often achieve higher rents, occupancy, and the buildings are rented out often before they're even completed. So it's also attractive for the consumer to come in and rent property in a place like this. They know it's going to cost them less energy. They know you've thought of daylighting and other things, so they know it's going to be a nice place to live. So what we're talking about when it comes to energy here is the dynamic thermal analysis versus the heating and cooling loads. So what's the idea with this to be? Whether you prove an energy label to say I'm a level A or B or C, what the dynamic thermal analysis, and this is with our software, and there's a few other softwares that are similar to this, like Design Builder or some of the more detailed analysis, it will give you a realistic idea of how much energy your final design is going to consume. Okay? Also, how to reduce the consumption of that design, how to optimize the performance of the systems. So not just designing an HVAC system and then saying it can handle the worst case scenario, but then going in and saying, what if I put in CO2 sensors? Or what if I put in temperature sensors into that system? What if I had automatic shading on the building? That's a big investment. How can you prove that that's worth having? And it will consider all of the building systems, not just HVAC. And then heating and cooling loads, they're going to give you a great tool to size your system, but it's the worst case scenario. It's not necessarily what's going to happen. Your building's going to be occupied. There will be solar radiation contributing to heat inside of the spaces. So that's what we're trying to say, is that often you want to do a bit of both. Okay, so we're going to get into some of these case studies from IES. So we'll start off very basic with some of the very simple studies you can do, very quick. They don't take long at all. For example, here is a good one. So what we have is 4 different classrooms that we're dealing with. And in each classroom, we have a slightly different design. And this is an example of what Ernestus was saying, where you can take the most early stage of design, and someone can come in and just say, I'm going to have 4 rooms. I'm going to have laboratories, I'm going to have classrooms, I'm going to have absolutely any type of space, and I want to test different designs. So we could be testing this for daylighting, for cooling loads, for all sorts of things. So we're making 4 identical classrooms. And the key with this is we want to vary it by changing the design slightly each time so we know what can happen. So here we have one type of window design with some vertical shading. And a solar heat gain coefficient for the windows of 0.65. So that's going to let in more of the sun, solar radiation. The second classroom that we have here has a different solar heat gain coefficient and a different shading device option. Again, we're doing the vertical shading. Then we go to the 4th classroom and the 5th one, or 3rd and 4th, either way. And you're going to change the glazing here slightly again. So what you actually might be doing in this case is we're just changing numbers, but you may actually have 3 or 4 different window manufacturers that are coming to you and saying this is the best investment, right? So you say, okay, fine, I'll test it out in this tool. So the first thing you can start to look at, And again, some of these projects are from the UK, some are from the United States. You'll see different units, but it's very flexible to be used everywhere. So we have the solar heat gain. So you can look in each side of the classrooms. Your cooling load is going to be affected by solar gain. So we can say this is a day in the summer. And you can see the solar gain, of course, is going to be the lowest in this one, where we're going back here. And we have the black line at the bottom. And that could be potentially the most expensive glazing. Then you go up to the next one, and you see that you're saving a bit more, but it's still extremely close to the cooling loads of the solar heat gain coefficient for classroom floor. So adding the two vertical fin or horizontal fins for shading versus the single one, then you can start to weigh across these options. What is cheaper in construction, perhaps, right? And do I want to invest in external shading? Do I want to invest in better glass? And then you see where the biggest jumps are. So when we look the difference between classroom 3 and classroom 4, you can see that our cooling loads and our solar gain has jumped quite significantly there. So then you would be able to start to say, I'm getting an idea of how good my glazing has to be. Once I get to a certain level, perhaps it's not worth me investing in a ton more, right? This is doing a good job. It's making the biggest step, and then I know where, for the money, I might want to stay. And this is, of course, something you want to do when you're in the conceptual stages of design, like Ernestus was saying. You want to make sure that you're testing this out long before it's built. Okay, so we have another type of energy analysis, which I'm sure you guys are all very aware of, infiltration heat loss, which can account for up to 40 to 50% of a building's heating load. So one of the ways we're doing this after the building is constructed is with building pressure tests. So we're going to see how much of the heating load is lost through the fabric, so just through the design that we've done on the envelope, but then for the infiltration loss as well. So this is a great thing to test, of course, after the building's built, but then you're going in and you're fixing it later. You're saying, okay, where are the leaks? Perhaps the window wasn't prepared properly. All of these other things. But you can start to test that early in design, and that's what we're looking at here. So inside of the tool, you have a very detailed library of materials. So you could have thousands of materials. We have hundreds that are already in there. You can see the materials from inside to outside. So it's like brickwork, slab insulation, concrete block, gypsum plastering, each the exact thickness that you're going to have for the wall, which is what a lot of the other tools will do as well. But when you run these simulations, you can start to test different things, like what happens if I slightly change the thickness of my insulation? And you can start to compare that against better glazing or other options. And it's also, you have the ability to do a condensation analysis inside of the software. So to see if there's an issue with condensation occurring inside of the wall and predicting that before you build your structure. So in this case, again, just a very simple way to test it with the building fabric. How much heat and energy are we losing through the walls? So you can see here, of course, with the glazing, you can see it on the left-hand side, the external glazing, you have the most loss, which we would expect, but also the ground or exposed floor is also quite high. So when you're going in and you're saying, all right, we've modeled an existing building and we want to make a decision about what to address, you could start to make some choices. And it's all about knowing where to go to make the biggest impact. Because, of course, adding solar panels will look great, but you can make a much bigger impact sometimes doing something small like changing that insulation or changing the details of your building. So now here are some of the very large projects that we've done. Calgary International Airport, this is in Canada. So we did a bunch of different studies here. So we have a double skin facade, displacement ventilation, daylight harvesting, automated shades, and hybrid geothermal. And is geothermal used here very much? Yes, okay. So that's a nice thing that you can also do with the software is we have a plug-in tool to actually design geothermal fields if you want to use it for that, and you can exactly put in your production from those fields into IES and use that as an energy source. So in this case, we're going to look at the daylight harvesting and the automated shades. So this is where it starts to get a bit different from just doing your basic HVAC system design. So here we want to understand if exterior or interior shading devices that automatically come down when a certain daylighting level is reached, how much electrical energy can you save when you use light dimmers, and also on top of that, how much cooling energy are you going to save? Because when the lights are off, we're not having the gain from those as well. Also, the amount of energy you could save by using step dimmers, which means we would turn off a row of lights at a time, or continuous dimming, which is like very smooth dimming. It's a bit more expensive to put those on fluorescent fixtures like here. So in this case, we would set up profiles. So with no dimming, we would have a very typical profile. It's a bit hard to see here. It's based on a building schedule. So you're coming in around in the morning, you're going to step it up slightly, then people are going to come in the office, the lights will slightly step down during lunch, and then slowly as people leave during the day, you're reducing your loads in lighting. But then the second thing is we're going to say, we're no longer basing it on a profile, because that's just something we're saying we estimate that will happen. We're going to do step dimming. So that means when we receive a certain amount of light at a sensor, we're going to drop the lighting load. And then the final one is instead of a row of lights, each light has the ability to dim itself and brighten as we go. And please feel free to stop me if you have any questions. So in this case, we're setting up a sensor in the space. So once this sensor is placed, we can start to run a simulation. And you see it says illuminance readings taken at sensor for multiple sky positions and conditions. So that sensor will read for every hour how much light it's receiving, and it will also understand how much solar radiation is going in the space. And then that's going to control our electrical lighting. So we're just looking at the exterior part here. You can see there's also external shading. Here's some areas. It's also important to note when you look at these spaces, you may see the portions of the space, for example, where there might be external items, like maybe there's an adjacent building or something, that will cause a shaded area, so that place may need extra light. And then the results from this, it's a bit hard to read it, but what you have here are the lighting gains. So with no dimming, you have, of course, the most lighting gains. And with no dimming, you're going to have the greatest cooling loads. With stepped dimming, which means going down a row of lights or perhaps one lamp in a fixture, when you turn that off, we're going to save on lighting gains and we'll save on the cooling loads because that's no longer adding any heat to our space. Also, with proportional dimming, we're going to see how that changes. So those are much more expensive, though, to add to your lamp fixtures. So the question here is, if you're consulting with a client and you want to sell them that we should do daylight dimming, you might be able to say, we can save 10% with the step dimming, and we can save 12% with proportional dimming. So the question would be, which one do you use, right? And then you can start to weigh them against each other. But in an area where perhaps it's extremely bright all the time, then you would save more with full proportional dimming. So it's always about comparing the products that are available on the market and proving how much you can make. Then we can also add, what this is actually proving operable shades coming down outside of the window. So here we have, again, we're looking at solar gains. So that's the amount of solar radiation coming through the windows. First part here is no shades coming down. The second one would be with shades coming down. So we would say at 500 lux at this sensor, we want automatic shades to drop. And then we also can do two things with that. We can turn the shades down and we can also have the dimming happen as well. So you can start to say, Are we better off investing in external shading or dimming devices? I mean, if you have to start making these choices, then you can really start to quantify how much you'll save. And in the next project, we'll look at how we translate that into money savings and also initial costs to create it. So, but it's a bit of detail that you add to your model, but it's a way to very quickly test and say, not just external shading, but internal, like Meco shades or something with a bit of light that can still come through. How much is that really going to save you in energy? So this is another case, and a lot of the cases that come to us when it comes to natural lighting are going to be these huge warehouses. So we get a lot of supermarkets, we get a lot of shipping facilities, we get a ton of, like, I don't know, the Walmarts or whatever else you have, these huge facilities where you have very big open spaces, and you can start to understand how much you're going to save by adding skylights into the space. When you look at supermarkets as well, it's actually proven that people will feel more comfortable and spend longer time in spaces because they have natural light as well. So it keeps people shopping a bit longer, but it also saves energy. So this is Bar Construction. It's one of the groups that we've worked with, and they work with Sainsbury's in the UK. And a lot of the large companies are investing in these sustainability plans. So if you have a huge supermarket chain, they probably have a goal for a sustainability initiative. And what those are going for, and this is exactly describing it here, it's analysis created by us that will work to support roof light design strategies within their real estate profile. So in many cases, we will get hired to say, let's take one of these supermarkets, let's run some simulations on it, and see if this is something that can then be applied to the total stock of buildings. So we have different ones here. So as-built roof design would assume a traditional grid. So that's the first one we look at. And then after this building is completed, if it's going to be a prototype store to be used again, you want to monitor and compare that actual energy use against your simulated model because you want to repeat this again in other locations. So we have trial of different types of roof light glazing, and we're going to try to understand which one of these designs is the best. So that's what this study is looking at. So we have here this large supermarket chain. Again, another problem in these chains as well is that we have refrigeration in one part and dry goods in the other, so we're trying to also balance that. We don't want a lot of electrical lights with refrigeration. Also, we looked at the use of different screens over the refrigeration unit. So here's an as-built roof light design. So what we're looking at is the different distribution of them. So the first concept that they had was a total of 72 roof lights over the main shopping area. And this is also taking into account the height of the building. Do we want it to be as high? Because if we drop it a little bit lower, we're going to get better distribution of light. So that was also a consideration in this, is changing what we really define as the height of that space if it's not necessarily required. So then we worked with the BIM model to coordinate that with the structural steelwork, because in many cases you're planning these designs of skylights, and if they're not coordinated with the steelwork, you end up blocking a lot of that light from actually spilling into the space. And what we did was reposition them to try to come up with some better options, and that's what you see here. So you see as-built roof light design, that's 4.2% of the area. The next one, we coordinated the steelwork coordinated roof lights, so we're spacing it a little bit better, and also then, of course, the product dials could be changed. The next one is the strip roof lights, where we're doing a long strip across. And then the next one is increasing the number, which is, of course, going to increase costs as well. But this is how it evolved. And the key here is that it's evolving before you get out. It's evolving before Someone goes on top of the roof and goes, oh, these skylights are all hitting the steel structure, and now we have to move them, and now we're on site, and now we're replanning again. We've done all of this stuff so that when the building goes to construction, it's done. It's ready to go. And this is really how it coordinated through. Because you'll see here also the increased number of skylights versus the strip roof lights. We're getting more light coming in, and we'll see how they distribute inside of the space. So we're looking at a sunny sky. And when you do the simulations, you're going to look over the whole year. But first you see how it works with the as-built roof lights. This is the lux levels in the space. The second one is the steelwork coordinated one, so we're doing it a bit better. It's not interfering necessarily with all the beams and the structure we have there. The next one is the strip roof lights, and we're getting much more uniformity in the space. So we're getting much more light coming down. And then the next one is the increased number of roof lights. Again, uniformity is what we're going for, so we're looking at how that comes through.
So it means that actually the decision will affect and what structure will be.
Yes, exactly. So, and the key here is that the engineer, the structural engineer, is talking with the architect during this process, not the architect saying, here's a design, you figure it out. And then the structural engineer having to go back and perhaps totally redo their structural system so that it can coordinate with this as-built roof light design. It's more of an interaction back and forth. When the model goes earlier to the engineers, the energy engineers, the other people who are on the team, these problems are solved earlier and you have a better solution. And if you're doing it at the beginning, you're not having to invest in the cost. And what this is actually showing the energy performance. So here, the highest levels are on the floor. It's basically showing on the work plane level where you have electrical lighting operating at peak capacity for over the whole year. Then you have these dips. So you can see where the skylights are on that floor plan. You have dips in the electrical energy being used the most. And that's also what you have here. And then on the last two options, with the strip roof lights or the other ones, you can start to see how that dips into how much electrical energy you're using. And for these big warehouses, you're using those sodium halide, huge lamps. They do consume a lot of energy. Then the next thing is, okay, we've defined we can save some money, but how do we start to change this in construction costs? Because that's the other part. And inside of our software, you have a tool that allows you to look at different study periods and costs of materials. So you can either use a library of materials that we have with life terms and all these things applied to it, or you can input custom materials as well. So first you have design one. Both of these are the same for our initial cost. So the same skylight, we're just repositioning them a bit. So you have your as-built roof light design, you have your steelwork coordinated roof lights. Here we're also considering the maintenance and the term of what's going to happen. How do we have to fix them over the time? Then we have the increased number of roof lights and the strip roof lights as well. So when you're dealing with just one long one, that's going to be less to invest in. You're able to maintain the perimeter of that a lot easier. You're not having to update it all the time. You're not having individual punctures inside of the roof where you can have leaking. All of these different things are thought of. Then you can see when we're looking at that cost, out of all of these, you're going to have the increased number of roof lights. But the strip roof lights are going to be the cheapest. Those were also giving us the most uniform distribution. So then we start to look at energy and maintenance costs. So this is again part of, it's really a three-part for this simulation. We have life cycle costing, we have life cycle analysis, and then where that's looking more at the energy or the details of the materials, like how green is the material, for example, if you have wood versus steel. In this case now we're looking at energy and maintenance costs. So you run a simulation and then you consider, of course with skylights that's not as insulating as your roof, right? So what is the effect on the energy? What is the effect on the maintenance over these years? So you can start to really break these apart. and say over 15 years, of course our initial cost was quite a bit less, so we're starting off lower. This is how much we've put for maintenance and energy to have those, what's happening over 30 years, and what's happening over 45 years. So we're knowing in this case, we also use net present value calculations, the CapEx, which will allow for annual roof maintenance and cleaning, and 25 years we're remaining constant for the cost. But it's this type of long-term scenario that if someone is interested in having the building for 15 years, it's going to be their building. This is a huge thing that can help them sway on what they're going to do. So then we want to, as an engineering company or as a development company, present this to the owner. And we have many example reports that you can use to present these findings. So for the first one, we have a summary of the roof light options. It was okay visually inside, but lacked coordination with internal structure, which when you were inside, it started to look a bit funny. Also, it had limited benefits from the daylight dimming, and it was poor return on initial supply and capital investment. So the next one that we go to is just improving the results by changing the position of those skylights, by coordinating it with the structure. So that was good, but it was still non-uniform, meaning the light was not, now the skylights are spaced a little bit differently, we're not getting a uniform spread. But it still wasn't quite achieving what we wanted. The next one was 126 skylights, so there was a lot more, but that was extremely more expensive by the capital investment cost. So it's really not a good option. And that was actually the worst score, even though it achieved better daylighting. So it's not necessarily about saying, yeah, we get daylighting, that's great. It's about what is the whole picture with it. And then finally, the last one was going to be the strip skylights. They're cheaper to install, cheaper perimeter to maintain. It provided that high uniformity in skylights. It was the 50% savings over the other options, and it had a good annual performance from daylight dimming. So after comparing all the options against each other, we can come to a solution with the architect to say this is the best investment for our space. And that's really what it's all about, is running the options. And this is a very simple one. This is not a fancy building. Some of these buildings work on, they're not the fanciest ones. But they are the ones that you can really make a big impact on by doing this type of study. Okay, another one we'll look at, it's also similar, but in this case we did it for Kingspan. If you're familiar with them, they do structures, prefab steel structures. And they also are a leader in high-performance insulation. So what they want to do is prove that their insulation strategies are going to work through using their brand, right? And that's also another question. If you have a brand you're looking at for your building, say Kingspan comes to you and they say, I'm going to save you this much energy. You want to prove that for the shape of your building and the size. Is the additional capital expenditure that I'm putting into this building going to be worth the savings, right? And in the case of Kingspan, I think they can prove it quite well. They want to have low maintenance costs. That was something putting in our software to be able to show. Reducing the carbon footprint was also very important. And sustainably reducing energy demand. Okay, again, another very plain building perhaps, but very typical, right? Shipping area or something like that. So we wanted to look at this zero lighting energy building, but also the benefit of this was that they were going to do the comparison against a baseline option. So we have option 1 for analysis included no roof lights and high pressure sodium lighting. Okay, so in these cases, we want to develop a baseline case. So let's say we go to, this is Tesco, it's a supermarket chain in the UK. Yeah. So we go there, we say, all right, we can help you out. Why don't we develop 5 or 6 tests for your future buildings that are going to be done, or your future distribution centers, and we believe we can save you a certain amount on what you're going to build in the future. And that's in the case for this. It was a group project between Tesco and Kingspan. So we developed their typical building. Okay? It's just typical. Areas are shown in white that are not of interest. They just have default settings. But then we have the other areas with the floor area. It's about 38,000 square meters. The external wall U values for the typical ones, infiltration rates, operation, in this case it's 24 hours a day, 7 days a week, and the occupancy density. And now we start to compare options. And this is exactly what you want to do in dynamic thermal simulation, right? You want to compare options against each other, and you want to very clearly track what's happening. So for the first option, we had typical high-pressure sodium lights, typical lighting power density required, no dimming, no occupant sensing, no roof light area, no PVs, which is photovoltaics. The question is, if this is the cheapest option to run and operate, then the customer is going to want to go with this, even if it's not the greenest. Then you have the next options, like the T5 fluorescent lighting, typical ones, lighting power density, it's a bit better performing, but again, no dimming. And then we add a little bit of the roof lights. Then we have the special polycarbonate ones finally on the sixth option, but you get the idea of how it works. And we start putting in like LEDs and different things. So we have overcast sky. You're always looking at a couple different conditions. What does it look like inside of the space? Average lux for the overcast skies, what we're getting. Again, this is showing when we're looking at red, we're at 100% of using the energy. Option 2, it's less because it's just the fluorescent bulbs there, but no contribution. Then we also have option 3, where you can see where those skylights are. We're really dipping into the energy that's consumed. So blue is the least energy that's consumed over the year in power in that area of the building. But also, these graphs all come out of IES. So this is what you use to bring to your client to a meeting, right? You don't go in and just say, I have an Excel spreadsheet. This is a way to clearly show a building owner how you will save it. And also, if you go for a proposal for a project, you can say, we've run 3 options and we know why we're coming to you with the best proposal. Instead of just saying, yeah, we designed this building and it was really cheap. If you can go in and you can prove that, I bet 3 other people designed it cheaply too, but we know in 10 years our building's going to be better for you, or in 5 years our building will be better for you. That's kind of the key here. And with the different options, you can quickly prove that. So you could just do studies at the beginning on different things. So, and of course, the last option, because we're using LED bulbs and all the equipment and the best performing ones, skylights, then you get a much better performance. Go into them again. And that's just, now we're looking at the different energy. So you see here we have energy performance year 25, okay? In these cases, we also will indicate if there is some dirtiness coming to the skylights, or that has to be maintained, and degradation of the bulbs or replacement of that, that's also considered in the cost. So if you're doing a life cycle analysis, let's say of this room, you're going to account for at year 5 or year 10 that this carpet must be replaced. Like, that's all part of it. Where if you were counting that this is going to be, I don't know, a vinyl wood look floor, that may need to be replaced at year 20. So you are trying to say, yeah, the carpet may be cheaper at first, but if you're planning on being here for 10 years, your cost is actually going to be more in the future. And that's what all of this kind of projection is about. And this is more of the electrical energy cost. So now we have all of our lights. What's the total cost? And you see, of course, we're going to have the lowest cost always at the beginning. And this is a great spot to be able to say, when you run these simulations, we're going to see a start of a payback period for some of these ones with the skylights right around year 4. I mean, that's a good thing to be able to show. And that's something that a building owner can really think about, where you start to have some of the other ones, it's a bit longer. The increase is not so much, but that's how much the total cost is going to be. So, also energy savings due to roof lights with dimming controls. And these are the different types. And then we have the total energy breakdown. So this is going to show how much you're spending in lighting on option 1 and how much in cooling. Option 2, lighting and cooling. and then, of course, heating some of the other ones, because you're not getting as much solar gain through those. They're higher performing skylights. So, and it's clear that the dominant energy for the building in the base case is lighting energy. And as the internal lighting gains decrease, this also reduces the cooling energy necessary to maintain the controlled temperatures in the store spaces. And of course here, that will also incur a small amount of heating energy because you're no longer offsetting the heating needs during that small portion of the year. So you do, by reducing how much you're doing in lighting, you may need a bit more heating, but of course you're really looking at the overall picture that you're dealing with. So that's what these are. And again, energy running costs, you're looking at the payback periods, and again in pounds, but you can put this in euros or any currency you want, really, and really start to show those payback periods for different options. And then if you're doing something like BREEAM or other things, you're going to want to show CO2 scores. Maybe people care, maybe they don't, but it comes down to costs for the most part, is how much you're going to actually save over that base case. And it's a huge amount. I mean, it's a much more expensive to initially build that structure, but in the long run, you're saving money, and that is the key. And option 6, where normally you go to a building developer, and I've worked in the field, and I've gone to a building developer and said, these are great windows, and they're so expensive, and they're like, no, we're not using that. It's not going to happen. But if you can prove that over 10 years you're going to save it, then it makes a difference. And again, we're doing a point scale, but you can really develop whatever system you want to express this to your clients. And in our case, sometimes we come up with points, we show scales, we show money savings. It's really the way you want to present your company. So I think we'll go through maybe one of the last couple ones. We can take a short break in maybe 15 minutes or so. But the next thing that we look at is occupant comfort. So what we've been looking at before is kind of the whole building. In some cases where you're working on a laboratory, or perhaps this is a school space, a laboratory where you want to make sure there's comfort, but they're also fully exhausting the air, you can do these CFD studies and daylighting studies in them. So first we want to look at visual comfort. So if someone's going to be sitting at this desk all day, I think there's quite a large pharma group here in Lithuania, correct? Like laboratories and different things. You are going to want to do a very detailed study of how people will be in that space and how comfortable it will be. So you can do detailed simulations of what is the PMV or PPD. I don't know how much you're actually using that here, but what it's saying is predicted mean vote, or percentage people dissatisfied, which if you do any of BREEAM or LEED or anything like that, you're going to have to prove that the people in your space are achieving a higher comfort level than other spaces, maybe other than code, basically. But maybe, I don't know if you have it for code here. You might. But in that case, also PPD and dry resultant temperature. So here we may have a space, right? You would never do a study like this for your whole building. But what you might do is take one space on each orientation, classroom, for example, and try to understand how the students who are sitting in that classroom feel in that space, on the north, south, east, west facades. How does the person sitting right next to the window? Are they getting the radiant cool feeling by sitting there? Are they getting a lot of air drafted down on them? Is the air going too fast in the space? Or if we're looking at this case in a laboratory, we have a fume hood here. It's exhausting the air from the space, and the cold air is going to accumulate and spill towards the occupants. So that's just an example of how we can start to prove, our spaces are working as we've designed based on where we've put our diffusers and our return locations. And also another thing with this space, you want to make sure all the air is not old. You don't want, if you're dealing with an infectious disease or some sort of thing with dust, you want every corner of the room to have the air exhausted and circulated through. So that's a good way to test it. And this is often used for hospitals or laboratories or dry rooms or particle rooms or these type of things. Also, you would use CFD for data centers if you're working on those, with the big server rooms where you don't want the temperatures to be exceeded. So just some quick final studies that we have here. This is another one. One thing he was talking about earlier was the rainfall and the water reduction. So inside of our tool, which I'll show you, you can quickly say, what would happen if I was to switch this fixture, like toilet fixture, water closet fixture, with something that used less water? How much would I save over the year? Or if I wanted to collect rainfall. So here we're looking at the building, and from the weather file, we can pull how much annual rainfall is coming from the building. So that is, I mean, just being able to explore those options. If someone wants to do rainwater collection, you may be able to achieve the same water savings by using reduced load fixtures. So again, it's not always going for the expensive option, but weighing options against each other. And that's what this sort of dynamic simulation is about. Also with natural ventilation. Let's say these windows can open when conditions in here are requiring, but they won't open if there's excessive humidity or excessive temperatures outside. So we can assume that, and we do this a lot in Germany, where all the radiators or chilled ceilings or electrical chillers will be turned off when the window is open. And what can we achieve by assuming that will happen, or by setting a schedule to open the windows? And often the cost of the sensors is going to pay back. This is a huge project we did. Of course, probably only stuff like this really happens in Abu Dhabi. But it was 8 buildings looking at double skin facades, automatic blind control. And again, these are much bigger than kind of typical projects, right? But it's very possible to do this on both a small warehouse and achieve that same kind of savings. And also understanding what happens if we compare like a double skin facade versus a regular facade. If an architect comes to you and they say, I've designed this great building, it looks great, it has a double skin facade, you can see if it's actually going to benefit you. In some cases, in some conditions, it doesn't. So these are quick tests you can do very simply on air temperature inside of the space to see if setting up a ventilation strategy, does it reduce the temperatures through a double skin facade. And it is used worldwide. It's used for very complex geometry as well. So you take something like the Grand Mosque in Abu Dhabi, you can connect to all of the 3D modeling software and import that into IES. And I'll show what some of those look like. But you can see here whether it's a airport, and I was at Riga actually coming here, and there are some issues that I saw we would generally get hired for where you have extreme glare. So like they put the screens where you have to read where you're going to your gate right in front of the window so you can't see anything. And that's often what someone who uses a software tool like this gets hired for. You get hired to fix a building with problems, to go in and improve an existing building. It's not just new buildings. And I think that's the key with this. We also are able to look at these thermal labyrinths under the ground. So if you want to have an intake and you have a thermal labyrinth under the building to bring the air to a more median condition like you would have in the interior, you can prove if something like this would work. And we also have some of the case studies. We put them up here. We have a net zero energy retail store. So this is, again, doesn't all have to be exciting building-wise. You know, some of these are just typical warehouses, steel construction. And then we also did Heathrow Thermal 5. So we worked on fabric air tightness and thermal performance were the best investments. More properties, a lot of these are for LEED, which we can talk about in a little bit. And this is kind of looking at what the geometry looks like when you bring it in. So you have a strategy here that an architect has developed. You can see we're actually pulling out the hot air through the building here, and it's going to come natural ventilation into the exterior. So we have cores that are ventilating through the roof. And as it's heating, it's rising and being ventilated. So we can start to see what the temperature in the solar chimney is, the type of air that's coming out, the speed of that air, and the number of hours per year if we are using natural ventilation or if we want to use heat recovery. And then also different things like Energy Lab. And this is something where you can actually get the type of simulation down to zero. But I think the key to remember with this is as much detail as you put in is as much detail as you're going to get out. And if you put in all the details, you can say that to your client that this is going to be within a range of what they're going to expect after it's constructed. And that's very different than like, you know, an energy label that says, yeah, this is an A, but they're performing very big within a range. And that's why in places that have energy labels, like France, they still use a detailed simulation software for the bigger projects. Do you want to take a break, or should that be? Okay.
We can discuss. We would like to have a small break.
No, fine. Yeah, exactly. Smoke break. Go on a second. Yeah, then we'll get started on the next one. All right, thank you.
So let's agree, 10 minutes. Is enough? That's what you said? Okay.
Okay, I turned off my
So let's continue. Start recording.
Yep, that's fine. Everything's good. Okay, so welcome back, and I hope that that beginning part was useful, and that you found that there are some parts of that that can be applicable. And now what we're going to talk about is how you would actually do these simulations inside of our software. So how is it possible to do it? And that will be the workflow portion. Okay, so now this is more what we're going into is kind of the typical demonstration of IES as a software product. It's a software and it's a consulting company, so it's kind of on both sides. Another thing that we also do is a lot of like European-based funding projects. So we work with cities to make their building stock more energy efficient and other types of things. But the main thing that we're going to talk about now is the software. So how it can be used, and you can see that also we have many experts at our company that can help you, and also through Ernestus and the Intelligent BIM Solutions team, they will also be able to assist you with questions you have. So you don't have to necessarily call us, you can call them. But typically, who uses this software? The number one group of people who are using it right now are engineers. And they're using it to provide services to property developers or building owners, etc. And HVAC, mechanical, electrical, building physics engineers. Then we have green consultants. So that could be green consultants for LEED or BREEAM or DGNB or Estidama, which is in the Middle East. It's their own version. But they're using our software to provide and prove that they have a sustainable design based on one of these systems. And we have tools that will guide you through that, which we can show you in a bit. Then you have the architectural people, and they're doing much more early stage analysis. So they're basically, like we saw with the classroom design, they want to compare 3 different classrooms before they go further into the design. They want to compare their designs early. They want quick feedback, and they're not telling the client this is your final energy use, but they're telling you this option may be the best one to go with. So they're doing an early stage analysis, but they're not necessarily providing like, this is how much money you're going to save. It's just guiding them on their design. So how do we get geometry into IES? So are a lot of people making 3D models now? Is that something you're doing with Revit or SketchUp and ArchiCAD? Yeah. And that's all something that you can bring into integrated environmental solutions software. And you would bring it into this 3D modeling environment called Model It. And you can also use GBXML or IFC file, which is something I'm sure you're familiar with, or SketchUp or Revit. So if you're not using any 3D modeling software, SketchUp is also a great option. It's really easy, it's fast to model, and you can bring in a very simple early design. So when we talk about early stage analysis for architects, we want to focus on what Ernestus was saying in the earliest stages. So programming, schematic design, I guess that's concept and proposal is what you were saying. And before we get to the final design stage. So I'm sure like in many other countries, it's very common that the architect will come to the engineer and say, this is the finished design, make it work. What we want to try to do, ideally with these 3D models, is get the engineer involved much earlier so that they can make some comments, or get the architect to have maybe a building design expert there who can start to do some early stage analysis. And one of the things we're very involved with as well is universities. So I've taught classes where we have an engineer work with an architect, or just an architectural class. First half of the semester, they work on designing a building. The second half, they only make changes based on energy. So it's very important that both the aesthetics or the looks of the building guide the design, but also what energy it's using. And then at the end, the stage where architects will pass off the design to the engineers, you can save and make much bigger impacts in those earlier stages than you can once the design is completed. Like you can do things like change the way the building is oriented on the site. And these are some of the questions you might be asking. So like what type of green technologies would be good? The architect is the first one talking to them, and you want them having those things. What's the climate of this site? How should this affect my choice of construction materials? Is this building internal load dominated or external load dominated? If I collect rainwater on the roof, how much water use could I potentially offset? So all types of questions you can start to answer. So how would analysis fit into this process? So at the most early stage of design, you're basically just focusing on the look of the building. And this is how we show people to kind of move through this. So you have many options on the table, and you're really experimenting. So you might have 3, you might have 5, I don't know. And these are the ones that you're bringing to the client. And every time you're having a discussion with them, you can say, all right, this looks good, this doesn't, but also this is how much energy it's consuming. This option may be 10% better than the other. Then you have the form. So you've got the general idea about the building, and you have a basic program that's inside. You know where your rooms are going to be. You know the basics, but you haven't totally finalized it. That's still a time where we can test different window layouts or like window to wall ratio, like 25% glazing on the south facade versus 22% glazing. What's the difference, right? I mean, you can start to answer that. If it's really making a huge difference, then you can say, we're going to do that. Then finally, when you have later design development, this is traditionally when the engineer is brought in. So this is when the architect says with the client, we're happy with this design. We don't want to move further. This is traditionally where an engineer is coming in anyway. So then you start to make other tests, like construction, the U value of the walls, the layout of the building, the window to wall ratio, or external shading options that you might look at. So the most important thing to remember at this time, and what we saw with the other buildings, is you always create a baseline. And that's probably what people will be asking you about here. If buildings are typically built to code, you know, whatever the government requires, make that your baseline. And every change you make after that is going to be, this is 5% better on daylighting performance, or this is 50% better on energy savings from heating energy. So you can start to make small changes, compare the design, but keep the glass, constructions, and building types the same. So basically, we just have our baseline building, and we're going to see how different forms are better. Later, we can test like glass and walls and insulation. And then you end up with something like this. And this, again, is just another take on what that could look like, right? So you have the take where we did the star rating system. You have this, which could be just a graphical way. And each of your companies can develop your own system for setting this up and expressing to the client that we've done a study and we know why this option is the one we're presenting to you. Not just because we came up with it or it fits on the site or we like it. I mean, that's great, but we also want to weigh them against each other for other factors. And now again, looking at the form. So we will set this as a general office when we're coming into out of Revit or out of ArchiCAD. And we will just test, you can see here, the windows are slightly different. And the depth of the building is slightly different. So now we can test this for daylighting and energy. And if our entire program, the scheme that we need to fit, fits inside, then we can really make a choice about these if the client likes the variations. And then finally, when you get into materials and orientation and later design development, you're starting to test other things like this. So what happens if I change the thickness of that insulation? What happens if I move the insulation to the exterior? Or what if I try a different strategy for ventilation? What if I try a different layout of the building? What if I put my kitchens or my heat production zones on the north side? How does that help? Because those are bigger loads in those spaces. So all of these tests can be done, but the key is to change one thing at a time. That's really the most important thing. If you change 100 things every time, like let's say we had a baseline building and then we changed the new building to triple glazing super insulated, great roof. Of course, it's going to perform better, but which of those things made the biggest impact? So it's about testing one step at a time to see how you can improve it and comparing it against a baseline. And that's really the most effective way to communicate with your clients. And this option of having the architect involved with you earlier is so important. And it's really good for the engineer if you're constantly working with an architect to say, hey, do you have a very basic model we can look at early in design? And then you can say, we can prove some of these energy savings, we can start the discussion, we can be there with the client. And that's ideally what a lot of people are trying to do. And now in many of the Scandinavian countries, you have people that are coming out of college and they're actually working, they're called architectural engineers, and they're mainly working on that gap between the mechanical engineers and the architects and being in the middle and really working on the physics of the building. But anybody can do this. I mean, you could have one person at your office who becomes more versed in these types of studies. But the key is that you have someone dedicated to looking at this on each project. So now we can talk a bit about the output from the software. So Model Viewer and Model It is the way that you build the geometry. You have different ways of getting rendered views out of it. You can get shading. You can do little movies out of it. So I'll just kind of click through it. But you can do all of these types of simulations, and this stuff, it also looks great on your website. For if you're showing that you can provide additional services, don't just do them behind the scenes, use it for your marketing. That's the key. Why is your company different than someone else out there? Because you have the capability to do this. So with thermal analysis, we'll go a bit into how we build an HVAC system and then how we would simulate parts of it. We have heating and cooling load calculations that you could be doing through other products. I mean, many people would be doing that through like DDS CAD or through Magic CAD or through many other products out there, or they could do it in our software. But then they come into IES to do the dynamic thermal simulation. And to optimize their system, not just to make it to hit the codes or to be able to handle the highest loads, but to change it and set controls and do different things. And I'll show you that inside Apache HVAC. You also have the window and wall makeup that I showed you before, CO2 emissions calculations, and natural ventilation, which you can do. So for example, if we're looking at the annual energy consumption, this is, if set up correctly, you'll see a sample output for thermal analysis. So the peak loads, in this case, for each room are calculated, and the system energy consumption is calculated for each end use, such as heating and cooling, lights, and plug loads. So if you build an HVAC system, you can actually calculate how much each fan or pump or other pieces are using as well. And the CO2 emissions are also reported, and you can also pull thermal comfort from here. You can also do thermal comfort analysis. Is this required here at all to do these? Do you know? Not so much? Yeah. It's mainly with, you'll see, sometimes it's required for the codes, depending on what country you're in, or it's required for some of the additional green rating systems. Because a big part of the green rating systems is not just saying that the building consumes less energy. There's actually portions of those systems that make the building consume more. Things like increased ventilation. So they require that the building gets much more outside air so that the occupants are more comfortable, or there's less CO2 in the building. They also require that you hit a shorter comfort range. So if you only allow a certain number of hours over 25 degrees for the year, the green rating system would say, we're reducing that. You can only go over for, I don't know, 100 hours a year. So it's about providing a comfortable space, but also providing an efficient system. And here you can also look at CO2 concentrations, peak daily cooling loads, and then you can go in and investigate your results. So why perhaps is there always a spike in my cooling loads here? If there's one room that's performing badly, could we go in and address this on a per room basis, right? Because you don't necessarily have to make the entire building if it's in the middle of the city and it's getting a lot of shade from surrounding buildings. Maybe there's only 1 or 2 rooms that really need help, and then you go and address them individually. So we have all different types of HVAC systems inside of the software, which I'm sure are like the ones that you're building in other products to do your heating and cooling loads. But here inside of IES, we set up the controls. So we're going to set up sensors, or we're going to set up different pieces for air and ground torque heat pumps, or optimizing our chillers, or setting up different types of fan controls and sensors so that they're not just meeting extreme loads, but they're meeting only what's needed inside of the building. And I know that some people also mentioned things like photovoltaics panels, so solar panels, solar hot water, wind energy, combined heat and power, biomass, so if you have some sort of wood chip burning, things that you want to account, or waste heat fuel, any of these things can be accounted for inside of IES. And you can also show different options. So here we have external shading on our building, on this one, and we might want to prove to our client that our shading devices are reducing the amount of cooling we need. So we can just use this to color by solar gain. And this gives us a way to communicate with the client that, again, is not a graph or just a spreadsheet. And energy modeling, metering, and model collaboration. So this is actually a bit of after the building is built. If you have an existing building that's performing really badly, you can take out the building systems data, so the performance of the fans or the performance of the chillers or whatever, and you can import that into our software, and then you can investigate it. So you can investigate, for example, are the dampers stuck open? Are the fans not cycling? You can start to see where peaks are occurring in the data. Our software can become almost a reader for these types of information from existing buildings. So you can investigate and say, wow, this particular unit is really giving me a lot of issues, or I'm seeing a lot of issues with cooling, and then go in and send out teams of people to fix it. And we actually have a system with a very large kind of like retail chain in the United States, where they're constantly monitoring their building. They have a weather station on top of each building. They run a simulation. At the same time, they read the data that's coming from their building systems, and they compare them. So if for some reason the cooling loads are peaking on the actual building but not on the simulation, they know that there's something wrong, and they can send out a team of people to fix it. And something like a damper stuck open or a fan not cycling will cost you thousands and thousands per year. I mean, it's something silly, but just sending out someone to look at it and fix it is saving and making it perform as you want. So that's the key with that. And also, again, more with comfort analysis, but if you are doing any of these pieces for healthcare or laboratories, this is something that will come up. You can also do solar penetration analysis. So you can see how much light or how much solar radiation is hitting the wall surfaces or the window surfaces. Another thing to remember when you're just doing your building by itself and you're looking at, let's say, the heating or cooling loads in the space, and you're not considering that there's shade from surrounding buildings, it's not necessarily accurate. And this will take into account everything around your building as well, and the effects that that has, whether it's blocking light or reflecting light or causing any other conditions. You can also look at where you might want to place solar panels on the surfaces. So in this particular case, you're looking at how much light over the entire year is reaching the surface. So you might know, all right, out of the entire year, this is the least shaded area, I will place them there. So it's just very basic ideas that you can study and work with. Then you have radiance. You saw a lot of the effects of this. This is where we get our daylight sensors from. We can also do the glare analysis. So will glare be a problem in the day in an office, for example? If you've ever seen any of these daylight buildings, I don't know if you ever see where people put up cardboard in their office because it's getting too hot to wear. I mean, it's terrible. They've come up with a great strategy, but it's not comfortable for people to work in there. It's not comfortable with the glare. It's not comfortable visually, and it's hot on them. So what was a great idea for daylighting can become a problem. So you're fixing that before it happens. And also changing your daylighting quality. You can look at tints on the building. So if you want to know what does it look like if I'm standing outside, how much can I see in, perhaps it's a school or a facility, a governmental facility where you want to have some reflective to the surface, you can change that as well. And also you can do very photorealistic renderings. So this is almost as good as you get out of some of the other programs, but the thing is it's completely accurate to the daylight, so you can have these readings. And there's nighttime light spill. I was speaking to someone earlier, and they were saying that there will be requirements for daylighting to happen inside of spaces eventually here, and this would be the way that you would prove it. You could say if there's a requirement for 200 lux levels for a certain number of hours throughout the year, you run a simulation like this, you show where it's happening, and that proves compliance. Or that could be for other green rating systems. And this is the tool for natural ventilation, which I'll show you a bit about in the program. And then finally, we also have a tool for evacuation from buildings. So this all tends to be a very specific group of people. I don't know if any of you will be here today, but if you have a life safety division, they often are doing some sort of evacuation simulations for how fast people can get out of buildings. And this is one of the two very well used tools on the market. And then you have people running out of buildings, basically. Okay. And then we also have step-by-step guides, which I will go into when we get into the software. You also have navigators for LEED, which we'll see a little bit. If someone comes to you and they say, can you do a LEED project? Have you ever done one? The answer is probably no, but the chance is that you can use a navigator like this to help you complete the project. Also with BREEAM. And then finally the tool, which we won't go on today because it requires to go online and to download the data, but it's the tools for life cycle analysis, life cycle cost, and capital costing. And this is where we got those results, where we were looking at the total cost to construct and bring a building into operation. So even I can't read this up there. It's talking about the amount that we're spending on doing on the site, how we're setting up on the initial cost. We can manually input this, or we can input it from a library. And then we get our details over the entire cost of ownership. So the first year is going to be constructing it, and that is a small portion of the entire cost of owning that building. And then finally, we have the life cycle assessment, which is going to allow us to look at environmental impacts of all of those materials. So as I said before, the environmental impact of using a steel roof, let's say, it's a bit worse at the beginning, but over time, it may actually hold up better because it requires less maintenance. So it's about trying to understand over a time period how efficient that building is. And the only reason you really use this is if you're working with a green rating system usually. Okay, but I will pull us into the product now so you can see it a little bit. So let's go into IES. And I think I'll be able to put up here. Yeah. So I'll have to turn around, make sure it's going online. Pull this out. Yeah, okay. So I'm not going to give a full demonstration of how to use the product in a very technical way. This is something that if you are interested or you would be a user of this, you should certainly attend. I'll do them online through the month, so you certainly just sign up with Ernestus and we can get you in on it to be an actual user. But basically you have some geometry here. you have the software. You will set up your weather file and location. It's quite easy to draw inside of IES. You're just going to draw forms, draw them on this type of view. You'll see your basic forms here. It can be very simple to set up your rooms and your spaces. So let's say we have a room, the height of the building, this is the group, or we can import it. So I know some of this is hanging off here a little bit, but you would have your import IFC or GBXML file. On the left-hand side, you have all of the different modules. So here would be where our results are. So let's go to the axonometric view. Let's just go to this model viewer. And this is an adjacent building. So this is causing some shade upon our building, but this could also be part of our analysis. And again, it's important to remember you don't always have to do the entire building. You can always just do 1 or 2 spaces and do those detailed studies on that. So the process we go through is we set up our location. So we'll just pull it up. It's going to come up on the other side. So we can go in and we can use a wizard here, and we can select our location. So and we have many, many locations. These are the locations we have in Lithuania, but you can also import from any other software that you're using. So if you have hourly weather data from another source, it can be imported inside of IES. So you basically are going to go through. You can set up your conditions on what you do here. You would use an ASHRAE database or whatever. You acquire your weather data, and you do your nearest to site. So that will tell you the location that's nearest here. And you also have the ability to set up a simulation calendar. So on the weekends, you have days off. So you would basically set up for your country the appropriate one. So you would base it on probably the closest and do a save as and do it that way. So that's the way that you navigate through. You've either imported or put in the material. Then you go through the individual components. And each group is going to have their own package. Like, no 2 companies will generally have the same thing unless they're doing the same services. We have some typical packages that people will use. You have your component library, so you can add all of the details to the space. You have Suncast, which allows you to look into the building and create images. So if I want to, a little bit off of my screen, I can go in and see how the sun passes through the space and how I can make surfaces visible or invisible. I can also run a simulation analysis to show the grid on the surfaces if I want. Apache Sim is my simulation engine. There's 2 separate ways to make HVAC systems. So the first one is to use Apache systems. It's a little bit, I think it's a little fuzzy. I don't know if I can focus it. Basically what you see here, it says active chill beams, central heating, hot air, fan coil system, and you have the different components here that can be controlled of that system. So you can look at solar hot water heating, you enter details about your system, what is the fuel. One of the nice things is you can also set multiple fuel sources. So you could say miscellaneous A, miscellaneous B, so that you could see exactly how much energy is being used by a certain system from that fuel source. Is there a heat pump as well? You can set these pieces. Cooling details, is there absorption chiller? What type of operation does it have? Setting up all the details for your scheduling as well can be done here. And then you also have details for cost and controls for it. So that is what we call the idealized or more basic system. So that's usually the type of system you're doing at the beginning. And when you run your simulation, you'll see here, I'm not clicking Apache HVAC. So I'm just coming up with a system that matches my details, and I'm running it from there. If I want to do a more detailed system, then I will go into Apache HVAC. So here's where I start to add a lot of my very details. Let's get a lot of controls on it. Let's pull this one in. So I can have as many systems as I want applied to my building. I have this green portion, which is actually repeated in the rooms, and then this is my entire system here. And again, I won't go so much into this because if you're not actually going to be using this tool, it might be a bit boring. But again, you can certainly attend a second demonstration with that in it. But you have lots of controls. So we have here controls that are controlling variables such as flow rate. We're sensing things like dry bulb temperature, CO2 concentration, enthalpy. We have time switch profiles that can also be connected to sensors inside of the spaces so that we can take the systems that we've designed and really control them and see, are these controls that we set on it something that will work well? Then we can also compare that to what a final building is using in the end, because often the controls part of your system is what's not necessarily implemented correctly, or people are overriding that, and that's why your building's not performing. So we can also import the other profiles that we want. So you have things like, I'll just open a few of the components. We have our hot water loop that we've set up in our space. Pull up a fan and pump. Yeah, this is our duct heat gain system. We have our heating coil. This is with a hot water loop, so we can actually go to our water side module here. And you can add all the details about that hot water loop and the components that you set in it. So you can go as detailed as you want. And we have a huge amount of libraries of systems that come with the software. But typically what your company will do is you may have 5 or 6 systems that you use regularly, and you will build them and you save them in the library, and you can always access them. You can also change performance curves, test different manufacturers against each other. So yeah, there may be 4 or 5 that will meet your needs, right, from different manufacturers, but you can go in and put their performance details in and see exactly what it's consuming as an individual component, and also do the same with fans to meet your needs. So that's Apache HVAC.
And again, just to remind, when I should use, why I should design engineering system here versus, for example, in specialized emission software. Where is the line?
Yeah. So basically what you're doing here is you are designing, you're taking a system that you may have designed based on your heating and cooling loads. This is not for construction, right? You're not printing this out and giving it to the building construction people to say this is the components you're going to use, but you're taking a system that you have designed and you're optimizing it. So you're saying, okay, I picked this fan because it was good for my heating and cooling loads, but actually I might not need something quite so big, or I could use a different component, throw it in here and see how it works. What if I had temperature sensors? What if I had CO2 sensors? What if I had natural ventilation incorporated into my scheme? How would that interact with my mechanical system? So it's taking what you've done, which absolutely needs to be done in MagicCAD or DBSCAD or ClamCal Nova, whatever you're using, and then taking that system and saying, I'm going to test it and I'm going to control it. And if you are doing it for these screen reading systems, it's often required to achieve the energy reduction amounts. So if you're doing BREEAM, for example, you can use what we were looking at inside of Apache Sim, which is the more basic system. If you're doing LEED, or you want to set up a really complex HVAC system or a complex building, you would want to go into Apache HVAC and do it. But every project will require something different, and every project is going to have a different budget for you to put the energy into it. But for Apache HVAC, if we have a huge building that we have a lot of details for, a ton of zones, a lot of green systems we want to see the effects of, we would use Apache HVAC. But for a typical project, it may or may not be required if it's a typical system. Then we can do macro flow, which if we want to set up controls for our windows here. So I'll just go to our openings. So right here, you're looking at setting an operable window. So what type of window is it? What percentage of that window opens? Do we have a schedule for it? Is it based on a sensor that's connected to our HVAC system? And that's also something that is very different with our software versus probably some of the other ones out there, that you can look in extreme detail at natural ventilation and work it completely in with your mechanical systems. One of the biggest issues, I'll say, in maybe Sweden, for example, is conditions inside of the spaces are very stringent. You can only be within a certain range of temperature and a range of humidity. So opening a window often gets you out of that. So when the buildings are designed, they do not calculate them assuming there'll be natural ventilation. But here, if you're able to calculate it in detail and saying we're actually controlling the opening of the building so that our temperatures are not exceeded, and if we are staying within that condition, then you can use that to contribute to what you're submitting for review. So it's about proving that your strategy will work. And it's basically a lot of that with the natural ventilation. It's proving you can use natural ventilation and still reach code. Other places like Germany, they completely allow natural ventilation. It's fine. So it really depends on your local codes, what's required by the system you're working with, and more. Then you also have your results here. So I'm going to pull up Vista. You have Vista on the left-hand side and Vista Pro. That will just come with the software. And you have all of your results files. So let's say we had the 3 results here. So glass with no shading, one with shading, and one with no shade. And we just want to look at the space for solar gain, like we have been. We can pull up and start to query that. So again, like what we were looking at before, where we want to see what's happening on a certain day. So we have our no shade. Of course, we're getting the most solar gain. The second one is with shading, and then the high performance glass. So in many cases, investing in a bit better windows is a lot easier than building external shading everywhere, right? So these are those options. And you can look in January, or you can quickly pop into August and see how different they are. So you could run these simulations with a detailed HVAC system, or you could run it just a basic simulation using one of our templates and still compare solar gain or still compare building insulation materials. So it can be very fast, or it can be very detailed if you want to know how much your buildings consume. And that's these just different pieces. So you can make all kinds of reports. You can do different range studies or tables results, so the solar gain in each of them and the peak loads for different times of the month. You can also do your range tests. So these are our peak days of the month. But we can do a test, so if you need to prove, for example, of course this is a typical simulation, that you have the number of hours over 25 degrees, we can test that for the year. So you have all of your typical capabilities of these systems, but also the ability to look at lighting gains, equipment gains, and the lighting gains, for example, that's something to really query when you're looking at doing daylight dimming. So you can run as many simulations as you want. You just name them something different. And this tool gives you the ability to test all of them separately. So if I go into my one with natural ventilation, I can see my natural ventilation gains here, all different heating and cooling temperature loads, and start to compare and really understand what weather variables might affect them as well. So it's very flexible in the type of results that you can get out. You also have here your daylighting tools. I'm just going to pop into this. So we're looking at our lux levels. So basically we just go and run through and run our simulations. We have the ability to do all sorts of tests on site of our space, quality settings that we can run, different types of sky files that we can test. And it's quite easy once you have a model. And that is another thing here, is that if you have a company where you're already offering energy simulation, you can very easily add another module and say, we'll do daylighting as well. So it gives you a lot of those tools. You also have Light Pro, Radiance, which allows you to look inside of the spaces and do these different tests. So you can do daylighting tests in the inside. You can set your daylighting sensors through here and components that can be inside of the spaces. So we're looking at lux levels, for example. But again, this is your energy model. So this doesn't take a lot more effort to add these types of studies to it. And then the life cycle costing here, cost plan, and environmental impact. These are the 3 tools that will allow you to do that costing for your software. The second tab is the navigators. So the navigators are essentially wizards that bring you through the software. So easiest way to describe it is it's just a step-by-step guide. So you have a step-by-step guide to do something like daylighting. Or import a BIM model, right? How to do that, how to get the layers to the GBXML and rename the spaces. Then you have much more detailed models that allow you to assign constructions or do something like, let's look at low and zero carbon technologies and some others. So here you have, for example, if a client says they want to use solar panels, you could test this type of solar panel, 25 square meters, against 2 of this wind turbine, against 1 solar thermal plate. You can also apply energy costs if you want, and then you can run simulations. And this can be done very early in the process. So this will run through really quick and set up the details. So there's a lot of different things you can do if I don't have too many things open. I won't run it. It takes a couple minutes to go through. But the idea is that you get up all these different reports, all of these different things, and it's all accessible through this model. So let's look at, maybe I don't want to bore you by sitting through 5 minutes of that. So let's look at water. So very quickly, if we want to reduce water in our building, we're not plumbing engineers, but we could say that we have 2 types of water closets. One is conventional, and that's going to be in our baseline model. And our second water closet uses 2 less liters per flush. And I also want to look at collecting rainwater and gray water. So I can hit OK, and I simulate this out. And what it will give me is, based on my weather file, I'm collecting rainwater, but I'm also going to see, compared to a baseline model, how much my proposed building used per square meter per year and how much my water decreased by, based on just using more efficient fixtures. Then I can go down, and there's a huge difference in costs from rainwater recycling to hand washing sinks, right? So once I pull that up, I can get my results on a graph that say very quickly, my hand washing sink reduced my water use by 19%, my rainwater recycling by 17%, my water closets by 12%. So I can take this information and bring it back to the designers and say, you know, I think we should really invest in different hand basins because this is 100 times cheaper than rainwater recycling, but it makes a bigger impact based on the number of people in my building. So it's about quick and easy reports at the beginning to push you in the right direction, but also the very detailed energy reports as well. But it's extremely detailed software. You can do many different types of studies with it. And I think that's really the key is testing it out, seeing what pieces may fit your company, and understanding where that might fit in. So I'll go close this out. And then very quickly we'll just go on to the next portion, but I won't go all the way in every single detail through it, but we'll talk a bit about the green rating systems and how these work with IES. So you saw some of those tools. If you're doing any project like this, you can work for LEED, for DGNB, or for BREEAM. And these are the 3 systems. I don't know how familiar you are with these green rating systems.
Countries is more green-based.
Yeah. Okay. So BREEAM is basically the oldest one that was developed. It's the most established in Europe. There are specific countries that also have BREEAM tools, and we have a guide for how you work through the BREEAM code. So let's say you wanted to create a BREEAM project, you would go through our navigator and say, I want to prove daylighting for BREEAM. Then you do the step-by-step guide, and this helps you prove it. So it's like a wizard to complete for these different systems. So for BREEAM, you would do that if you have a BREEAM project. So you would have the regular tools, then you would just buy a tool to help you do the BREEAM studies. But really, all of these different systems look at many different conditions. LEED is going to be the most based on the energy consumption of the building. BREEAM looks at many, many credits, but especially CO2 emission reductions. And then in Germany, DGMB is looking at the entire life cycle of the building. So they're very concerned with how the building materials are resourced, where they're coming from, many, many details with that stuff. And they're in Denmark, so I pulled this from Denmark. Yeah, and just different portions about LEED. I won't go so in deep to it, but our tools help you do things like the water efficiency credits or the energy credits for it, and they make it very easy. Also for LEED Italia. And if there is a system here that would be good to use, it's something that we could definitely consider making something for. So but it's really, for the most part, if you're just doing general tools, you'll go through our general navigators. You'll figure out how to reduce energy. And then if you do get a project in one of these cases like BREEAM, you can add one of the navigators to it. And it's a very step-by-step guide. Also with DGMB, you have your water consumption, your thermal comfort, your visual comfort can be done. And these are just showing how you complete those credits. And this is for BREEAM. So you can do like views out, daylight, potential for natural ventilation, indoor air quality, CO2 emissions, all this stuff, material specification. And this is the reports that I didn't want to say. So there are 5 minutes of it running, but you get a report, shows you your proof. In the middle, it shows you whether you passed or not, and tips to improve it. So that's always the form of the report. And all of these companies, whether it's the BRE, or LEED, the Green Building Council in the U.S., which manages that, they are used to seeing our reports and accepting it. So it's something quite common that they do. Okay, I'll just click through some of these, through them. But you get the idea. It's a lot of this type of thing. Same with the environmental impact. It can also be used for BREEAM. And this is also showing some of the costing here. How you can define exactly what things cost, how you input the life cycle cost, and how you can use the library. And you can actually go down to every year if you want to see where the costs increase. And it's also compliant with European regulations.
So is here also, let's say, BREEAM navigator, so it's for process.
Yes, for process.
For scoring.
It is for scoring. And also there is an online project tracking system, which we will not totally open, but that's also another demonstration. So it's a lot of stuff to go over in one day, but there's certainly a lot of pieces, and I hope that was helpful.
Just one question, and probably we should start discussion regarding what is your experience and in other countries.
Yeah.
Actually, in our countries, architects nowadays don't care about, let's say, energy things and let's say, so in our case, should we just put together in the project some energy expert or whatever together with architects, or even in our universities, actually architects not study energy questions. I think, and you would propose, you mentioned that in your practice there are half-year purely architectural things and half-year energy things. So.
Yeah, that's in special cases, I think. I mean, it's really, every country is at their own stage of this. I don't think anyone's perfectly doing the perfect design. Everybody knows that you must work together with energy from the very earliest stages to make the biggest impact. That's very important. However, there isn't always the money in the architect's budget to do that. And this is the problem. So the question is, how do you prove to your client that this is something worth them investing in? And that's really where the next part of money comes in. You want the architects to do some preliminary analysis, but you as the engineer can also really come in and prove this is how much you'll save, this is how much, this is what you get by having a team that works together from the beginning. All of these green rating systems in other countries, they give you points for just having a meeting with the engineer, the architect, and the building owners. Just having a meeting, you get points because so much is done just by getting people in the same room to discuss stuff. So I think it's important, of course, at the university level that students are given access to this and that they can start to make these studies. It's also important that the clients are demanding it, that they're not saying, you just give me anything and I'm expected to take a guess on how the building is going to perform in the end. That is also a big issue. And also enforcement of this during the construction process. So if you've got the best windows, but the guys who are putting the windows in are not sealing them properly, then you also have another problem. So it's a whole scale of issues along the whole thing. And I think in Europe, we see some countries have developed their own rating system. This is very common. Some countries have great rating systems that tell them exactly what the building will consume. Others have some that don't, like France, as I mentioned, so they use another program in addition to it. And some countries have no regulation at all and no enforcement. And then you really have to come back with an explanation of money. This is going to save you money. This is why we're doing it. We're not doing it because you just have to check this box. We're doing it because in 5 years you're going to save that. And so it's usually that discussion when we come to.
And in our Baltic country situation, actually, what is your vision or recommendation how to start all those things? Actually, probably we should we discuss together with you about maybe some cooperation with academical institutes and universities, and to train to actually their knowledge how to do that, how to think.
Yeah, of course. That's one thing we do is we'll definitely provide free software to academic institutions or people that want to do their thesis or anything like that. It's something we completely support, and also having people that are really interested in it. We know that you might need more support at the beginning, but that's fine, you know, and that's what Ernestus was saying. That's something about your company that you do, is it's not just the software, but it's showing you how to actually sell it and how to, you know, sell your services. How does this actually help you, and how do you push it across, and how do you get staff from the universities, right? And I know you guys are involved with that, and I can't necessarily say what right or wrong path for the Baltic countries. I don't know. I think you guys will know a lot better than me, and it's just finding the way that really sells it to the owners. And also, we only see a lot of movement through the green building councils. They're often a great hub to get involved with, to see, are they developing a local scheme? Are they interested in BREEAM? Are they interested in DGNB? Are they involved with the government? Are they, you know, and I would recommend any student go out and try to be involved with the Green Building Council. And also people considering members of these organizations, because they do help you quite a bit.
But one of the problems is that we still don't have experts, high-level experts. So we should care about educate.
Yes, of course. Yeah, education, I guess, is the best. And and I would take your recommendation on that, definitely.
Klausimų. Šiaip turim laiko padiskutuoti, pritaikant prie mūsų situacijos. Any questions or discussion how to adapt all those things and start implementation in Baltics?
Well, it's free of charge. Pay for the software.
Oh yeah, it's great. Do you want to come up here so they can hear you online?
No, of course, we have chat, but we are willing to prepare, let's say, we should care about academical things, we should care about other things in order there will be not only demand, first of all, there should be demand. So customer, property owners, state should start thinking about that and should ask about that. And from another hand, we should prepare specialists who can do that. So we're open to cooperate with Riga Technical University, Vilnius Gediminas Technical University, Kaunas Technical University, in order to help them to prepare, first of all, to start thinking a little bit another way, that architects and engineers should cooperate together, or at least maybe there will be some architects, engineering-oriented architects, for example, and we can help with the somehow participate in training programs, to integrate that to training programs and somehow. So two things, demand and supply, training, and then it will start work. But the key is to change the mind, because we are not thinking this way. And by the way, about Green Building Council, as I discussed, not too much companies, property owners knows about Green Building Council at all, about this organization, what they are doing. So we should be more proactive in marketing and thinking, first of all. So our company, with partners, are ready to support all this process. But we can think about simple question, and we can discuss it now, how immediately to adapt something.
Do you have special condition for universities?
No, I think yes, it's not standard condition, but we always can agree on that, yes.
Yeah.
We can discuss that.
What about other things? You mainly spoken about energy, about daily life, about shadows and other things, about these things which are very important for these rating systems, these things like sound insulation, fire protection, I don't know, maybe eye quality too.
Yeah, so
Game,
with those tools, a lot of that has to be done outside of sometimes a simulation program. So like if you're doing sound insulation, it's not necessarily a simulated thing. It's either proven or there's a reverberation test after that's done in the space. So it's more of like a sound calculation. And with some of the other ones, it's not necessarily requiring a simulation engine. Like what's a good example? Like low VOCs, which are volatile organic compounds. Like you have to prove that all of your paint is a certain level, you know, and this is completely outside of IES. It actually is just usually the assessor who's going to be gathering a ton of data. And then you maybe have the engineer who comes in and they do the portions that require simulation. But more and more of that can be done inside of the software for LEED, like you can do the site design and these types of things. But I would say for DG&B, for example, you have a big portion of that that has nothing to do with simulation. It's a lot of data gathering, a lot of resource gathering, proving, for example, that your wood came from sustainable forests. Another one is if you have stone, like that you're going to use on the floor, you have to prove that it had not used child labor, which has nothing to do with simulation, so you have to do a chain of custody and prove it that way. So a lot of that stuff is not a simulation-based piece, but this is a big portion of it. And often what happens is the assessor hires someone else to do this part. The assessor outsources it to a mechanical engineer or to someone who's doing this part. They pay them to do that, they assign them these credits, and then the assessor does kind of the information gathering and the other pieces. So each system has different requirements on that.
And, okay. We are going to design buildings, and are you going to check it how it's working after 5 years of the, I don't know how.
Yeah, I mean we highly recommend you do that. Yeah.
I mean, what's your responsibility if you are, for example, design something, say okay, it will be good, it will work for 25 or 50 years.
Yeah.
Okay, it's about the responsibility.
Yeah.
Okay, we are going to check. I'm, for example, developer, and
I see, yeah.
Okay,
We should split the two things, software and services.
okay.
Yeah, well, I mean, I think like if you're doing this with the software and you are, let's give an example. We did a project with Walmart. We had an extremely large amount of money to put into the project. Our predictions were within 3% of the electrical energy use and 2% of the thermal. That's because we went as far as creating profiles from exact number of people in the building. You may not have that budget on your project, okay? It's too big. So your tests your ranges are going to be different. What you can tell the client is this option may be 5 or 10% better, but it's within a range because you don't have necessarily the budget to make an extremely detailed model. If you do, you can get very, very close. But
How much close?
like what I was saying, within 2 or 3% of, because occupancy changes and stuff, I mean, that's really what a lot of that goes down to, but you can get very close. But that needs to be a big model. I would not be guaranteeing from any of you to tell someone you can get within 2 or 3%. I think you should say that we're doing this type of analysis. We're putting in a lot of detail to it. This level, we could get closer, but in some cases, you're not guaranteeing that. You are saying we're going to aim for this sort of energy reduction because you as an engineer cannot control how everything is built on the site either. In most cases, you can't control the whole chain. So you say, this is how we've simulated it. It's going to get close. There are cases in the United States where people, of course, suing everybody, but they sued because they did not reach a certain level of certification, like a green building system or for LEED. But that's the key. You don't say that they can. You know, you try and you come in as a consultant, and if it's built as you say, then it's fine. But for the energy and the electrical simulation, if you're involved in the whole design, you can get very close. But we always say garbage in, garbage out. You make a bad model, you're going to get useless results. That's the key in any case. So you have to learn it. You have to do your process correctly. But there's nothing wrong with an architect doing a very basic analysis at the beginning and saying, this building could be 5 or 10% better than this building. Even if you're within a very big range, you could still get guidance from that to say that this orientation for my building is better.
That's government requirements, government rules, how sustainable a building have to be in the United States or UK. For example, in Latvia, it's just 2 years. Okay? It's enough 2 years.
That's enough, yeah.
We start and end this gap 2 years.
Yeah. No, I mean, it depends. Some of the government buildings in the United States require them to be LEED silver or above. Some particular buildings in Germany are requiring a certain level of D, G, and B. Some other government organizations, like in another country, will require that schools reach the level of their own rating system. So it really varies. It's quite varied everywhere. But I think, like, even what you see, like some of the stuff that we put up at the beginning, every one of these European countries is signing onto these initiatives. We're going to reduce energy. We're going to do this. We're going to do that. And eventually these are going to come in as codes, you know, and they're going to have to be met through the building stock and through infrastructure. And I think that's what we see is that codes are being developed slowly in all countries, whether it's in Italy or in Portugal or in Poland or especially in Scandinavia. They're very strict with it. So it's slowly changing. Dynamic simulation is slowly becoming required everywhere. I have no doubt that that will be required here at some point. I don't know when. I have no idea. You guys know better than me. But it's something that slowly each country is doing, and they will set a label for it at some point.
Yeah, we need to put more efforts that it will go from government point of view. Some initial requirements, because now it's nothing.
Mm-hmm. So yeah, I mean,
organization should care in Latvia, and we building council Lithuania should care about ours.
But you can do it two ways. You could say, I want the government to do it, or I can sell it on money, right? There's two different ways to look at it, and I think that it can be both, right? And that's how the codes in the U.S. are really bad, but they love to market buildings as green buildings, and they also love to do this LEED stuff, and that's how it goes through. Scandinavia, no, this is how it's going to be. This is what's happening. Everyone's doing it. So two different ways of getting to the same result.
What about the buildings types? Which, let's say, there are some, let's say, buildings like supermarkets, warehouses, commercial buildings, let's say. there are apartments
Yeah.
buildings, and there are, let's say, offices and other type of buildings. So, from your practice, which type of buildings, from owner point of view, is more required this building performance analysis? Can you just read that? Okay.
I mean, we're generally not doing it on a
apartments.
house. I mean, that the amount, you have to look at the budget for the project. That's really the issue.
For example, apartment house.
Yeah, I mean, you can do it in apartments, absolutely. The difficulty in apartments is the user controls many things after they move in. So that's one of the things, and they control the heating and cooling. But every building can benefit from just looking and saying where are the best investments to be made for insulation or windows or anything. I mean, I live in Switzerland, and the difference there between the amount of energy I spend to heat and cool my house compared to when I lived in the United States is extremely big. I will always look for a building that is a greener building. It's more comfortable to live in. The codes require it there, of course, but it's, yeah, I mean, it's a really big difference when you're an occupant of that building, what it feels like. And for apartments, I think that
So this is exactly the big difference between the United States and Swiss people.
oh yeah, big difference.
Exactly that.
Yeah.
They need.
And the difference between Swiss people and, or even any countries, you know, I mean, I'm so surprised the difference between Norwegians and Swedes. And everybody has their own way of going about it and their own way of coming to the conclusions of what's right for their country and reducing their dependence on energy from other resources. Obviously, Germany puts a lot into people having solar panel fields, and they get that sent back into there, and they pay a high amount for the energy put back into the grid. So it's going to be a different solution everywhere. But part of this is just, I mean, the key really here that we're looking at is reducing the amount of energy your building consumes. That is the first goal. If it consumes less, then you're already ahead, right? And that means money savings, that means less CO2 emissions. Maybe one day that'll mean government credits for money. I don't know.
Yeah, and you know about our Baltic countries, some obligation.
Yes, and you have these things that you've signed on to with the EU. You have a lot of green initiatives that have been signed. So that's everywhere in Europe.
Time is running.
Yeah.
Qualifying is 20, but time is running and
Exactly.
what
2020, right? I think that's what we looked at for the reductions.
is about results.
Mm-hmm.
Maybe what's your point of view about assessment of this building? The building is built on the good design and assessment of the green, or LEED. I think is it more or less can you sell cheaper or more expensive this building? Or is it just for image more?
Well, it's less often to operate the building with energy costs for heating and cooling. It's some of the arguments for LEED are that, like, the number of people that are sick. Like, if you have an office building and it's LEED certified, they've done tests that because of the increased daylighting, because of the increased ventilation, people are at work more. So the person who owns the building can prove that because the occupants are more comfortable and they're not breathing each other's air all day, they're not getting sick, and thus the building owner can save money from everyone not being sick. But these are like way steps off, you know, like from what you prove. But now these studies are coming out that there's been a huge difference. And in Germany, that's when I was at the DG&B training, that's a huge part for them. Their DG&B apartments are rented at a higher rate and faster than buildings that are not certified, and their offices are the same way. And does it really matter if the guy who's renting the space is a good person or just wants to put up an advertising? It could be either. But yeah, it really depends. And so they're seeing a lot of success from that, in that saying, this is a green building, we want to move in there because it fits with my company image. So you have a daycare for children even, or you want to put your kids in a building that the paint is not, you know, a lot of volatile organic compounds. So, or where you're living, you want it to be more increased ventilation. And For example, in Dubai, that's where we work a lot as well. Someone moving into one of those towers, you're going to live 6 months out of the year without opening a window. Do you want the building with increased ventilation or not? You start to think a bit about it as an occupant, and people feel better in those buildings. But yeah, it's a huge question everywhere. I think it's so many different points to address with it, and I hope that it moves. It's moving very quickly now. I mean, we're seeing a lot of people moving into it, and there are a lot of companies here that do work abroad that, for example, portions of bigger companies like Skanska or Sweco are interested in doing that type of stuff. So it is spreading, and that's generally how it goes. The big international companies bring it in, bring in this type of simulation, they can offer it. And then sometimes we see smaller companies become more specialized and offer it, and it spreads that way. For our library? For which portion of the library? We have like the construction materials. That is based on manufacturer's data, and then you would also be able to build your own construction materials. If you're talking about the life cycle analysis or the life cycle costing, that was a project done with BREEAM for, I think it was about a 7-year project. And it was all to create this database of materials. And BREEAM is actually the owner of this database. We just provide a way to interface that database with our software. But it's European compliant, so it can be used for BREEAM or it can be used for other different types of life cycle analysis. So it's actually this part of it here. I'll show you that. This is what is required, like life cycle stages. It's all compliant with these codes that have been set up for life cycle assessment. So this is what it's actually coming from. And all this research has been done by the BRE. And slowly more and more manufacturers around Europe are putting themselves into this library. So it's growing every day. So I was just talking to a cement additive company like Bast, and they are going to be putting their materials in here as something that will be added. So, I mean, ideally, this would be easiest if we had a material of every single manufacturer.
And in your library, there are some kind of materials or some kind of windows. So
yeah, there's all kinds of windows. Those come from manufacturers. Those come from typical windows that you have on the market. And then, say you have a window you're always working with, you can create the conditions of that window in the software. But the life cycle analysis, that's probably the most complex portion of input of materials. And that's done through the BREEAM library.
How many software users do you have this?
In Lithuania. Yep. Yeah. We
from the beginning, let's say.
Yeah, not a lot. Put it that way. This is kind of our first time coming here, so it's yeah, not many. Maybe some of you guys.
But
I don't know.
Now,
Yeah,
let's say a few companies which are working on that.
there are. Yeah.
Which are learning that, and we are expecting some results from that.
Yeah.
One of the companies, EE Blues, which was small and specialized, let's say.
Yeah.
Spec also looking for the solution.
Mm-hmm.
Hobby
Yes.
also working with that. And there are decent energetic sprending, which also start to do something with that software, but it's not too much.
And sometimes we'll get like, let's say in Poland or in other locations, we'll get like one user there because they're doing work for another office. So like, let's say you're doing work for the Stockholm office or the Helsinki office of Brandland. Then they get a couple of users here that will work on the software as well. So it tends to be, it's brought in sometimes by the bigger companies.
Yeah, but actually it's on
In here, yeah, it's only at the very, very beginning. It's not anything.
That partnership on it's free.
Yeah, exactly.
So, any other practical questions?
Who usually provides such kind of services? What type of components? Architect bureau
Yeah.
or some consultant?
Generally, I would say only the very cutting edge architects are doing this. So they probably would not be what I would see as the first users, unless there was like a really young or young mentality firm here that would love to do that. It's often a partnership when I see with architects, but an architect and an engineer kind of who team up to do something.
How many architects?
Yeah, how many architects are
here?
doing?
Please just raise the hand. Kiek iš architektūrinių įmonių? Padarom eksperimentas.
Yep.
One.
Okay.
How many engineering companies are here? Wow.
Okay. Yeah. That would be more our base,
How
I
many
would say.
property developers are here?
Okay.
Okay. So this showing who is interested in that.
Yeah.
And who will work with that.
Yeah, but in Western countries.
Yeah.
In other countries, it's still, I'd say the breakdown that I see here, actually. It's still a lot more engineers are doing this type of simulation because they have the building physics background in school and knowledge. Now more architects, perhaps in your program, you're learning more building physics, then you can use these type of tools. And then the property developers are always interested as well in being clients of this sort of thing because you can save money on your property stock.
This is what we're always speaking when we're speaking about BIM technology, BIM methodology. We should understand that project is not started and continued by architects. It's group. It should be team from the beginning. Team. Let's assume architects. Let's assume energy consultant. Let's say. Let's name it energy consultant. Let's name it, I don't know, energy supervisor or whatever, which stay working together with architects and care about all those things. And not allowed to do what architects love. You know, sometimes it could be just separate project, separate study, before going to technical project, for example.
And someone was asking online about the SketchUp program being used as the main program for serious projects. I know SketchUp seems like it's really kind of a simplistic tool, which it is, but it actually doesn't matter. As long as you can pull the geometry into IES, it doesn't matter if it's through ArchiCAD or SketchUp or, I don't know, make up a program. It doesn't matter how it comes in. As long as the geometry is sound, once it's imported into IES, it becomes, it's sound enough once you fix it up, because that's where you add the detail. It's done inside of IES. Exactly. It doesn't depend on SketchUp. So these buildings here that I'm showing, they're super simple, but the detailing is done in IES, so this could come from any program. Doesn't
So
matter.
let's name it that in ES you are making decisions.
Yeah.
You're making comparison, different solution, and then you continue in architectural software or engineering MEP software just to realize what decision was made. So this is the process, not to play in architectural or structural engineering or MEP software, 5.3, 5.7, many versions. Then we come to trouble with the technical project, or even in construction project. So just it's for decision making. As I mentioned from the beginning, it's what and why should be done. To prove what and why it should be done. To calculate, just calculate, not guess. And then we should go to the usual our project tools. That's I wish BIM tools, let's say, because it's another benefit for construction, for let's say also not only for construction, but benefits for facility management, for building maintenance, but we should understand that this simulation software will help you to make decisions and to choose most valuable solution from comfort point of view, green, let's say, policy point of view, and cost point of view, construction and maintenance cost. And by the way, what is your knowledge? How many proportion? It means our construction companies, our owners, very focused on construction cost.
Yes, yes.
But they don't have chance to, let's say, to measure all and precise, to measure exploitation cost.
Yeah.
So what is the proportion?
That's why you have to convince the building owner. So when that construction company goes to them and says, why do we have these expensive windows? We can get these other windows for a great price. And that building owner 90% of the time says, yes. Okay, great. Or we can get rid of this external shading. It's costing a ton of money. That's when the building owner says, oh yeah, that report. I saw this report that said I would save 30% energy. That's why it's there. It's not there because the architect felt like it. It's there because it has a reason. And that it is a defense against getting cut out. That's essentially what it becomes. It's the facts that you use to defend cutting it out of the project. We all deal with the same thing. Every project, doesn't matter what country you're in, the guy goes, yeah, oh, these windows, you're buying these windows? You know, I have a much better company from here that I can get these windows. Or why are we doing this type of insulation? We can make it a little bit thinner, or the code only requires this. Why are we doing this? That's always the question. Every project, same thing. It's just a battle of it every time. But if you've proved it will save energy, there's a reason why.
Yeah.
You know?
Please convert energy
into money.
means money.
Yes, exactly. And then if they go, oh, well, maybe we want to cut this, and this has a 20-year payback period. Maybe that would be cut, but if you have something with a 5-year payback period, then that stays. You know, and it's all about that. Like some projects we get brought in, they worry about 20 years. Some projects say if it doesn't help me in 5 years, I don't want it. So you work within that.
Which payback period is?
Well, it depends what company you're working with. That's really what it is. I mean, someone who has no interest in being green and is only in money, then they have a lower payback period. Someone who is working with DGMB, like Germany, they're looking at 50 years because they have no choice. That's what they require. Yeah.
What's proportion to sustainability rating systems? Okay, you can offer your solution just about lighting and energy safety setting, and but how is important this sustainability rating system? Is it in order to get green or other assessment, or is just to save money to keep better? How is important the sustainability issue?
Well, our company has been here for 15 years, and only in the past few years have these rating systems become very important. I think now those have made it much more required than they're required to use something like this, but in general it has been kind of a money thing or a code thing before that. It's always been required like that.
You know, cost and efficiency always will be here. But I think that to our countries, to both countries, here will come those certification.
Yeah.
It will be anyway, and it will affect all building industry.
Or you'll make your own. I mean, that will be the other option, right? You'll have your own Lithuanian code system that does this type of thing.
Yeah. Or we can just to create Baltic some code system. This is your organization, probably should manage that.
Mm-hmm.
Any other practical questions? How to adapt all this thinking to our situation?
But I would also say you can download the software, and anyone who's here, we can give you a bit of extended time to test it out. Try it on a project. Are you going for a project? Test it out. You know, see what you can do. I mean, that's a big part of this. But make sure you get assistance. You're not going to be able to open this and be like, oh, I've saved so much money. You know, you need some help, and you'll talk to Ernestus about that. How do you make it part of your design process? So that's kind of the hardest thing at the beginning. But if you make a goal, like we want to prove daylight dimming in this structure, we're going to go to our client. He's going to think we're crazy. We've never mentioned this before, but we're going to try it. And you can go in and do that and make that test, and you can see how it pays back, or include it in a proposal. Include it in your, RFP, your request for proposal. Put something on the front that says we've considered 3 options. See what happens. It's all about that. You know, does it make you get a project better?
Yeah, I oftenly hear from design companies, engineering design companies, one argument. Who will pay for that analysis, and why will they come in our countries, our companies which can provide this type of services, even not feel the added value to customers. And they say, okay, who needs that analysis, kind of analysis? Who will pay for that? And we're starting, okay, now what? So why I should do something? So this is the key, to understand added value, to show that to customers, and to save customer money. So if we still have Lithuania, probably Latvia too, why we need that? So we are so far from the, let's say, Europe or other countries level. If we know why we need that, so there are another type of question. Who will pay for that? So, or how much it can cost? Is it reasonable price or not reasonable? Because I have a lot of opinion that, okay, no one will pay for that. But it's also not true. True is just one. You not show results on that, and that's it. So it means, again, customer education. Education, our engineers education, architects education, customer education, education. So this is what we should be ready for. Educate our market and develop all those ideas.
One question more. So how soon can we wait for IS educational community or something like that, which could actually help to educate not only the market but the architects, engineers, and all other specialists? Because there's a huge Autodesk educational community which helps a lot.
Yeah, okay. For that point of view, I see two ways how to help our market to prepare engineers for that or architects for that. Two ways. One way is to get partnership with our technical universities. It's one way. General understanding to increase their level. I know good examples, and we're talking now with Vilnius Technical University about possible program how to integrate that. And another educational possibilities. If you are not student, let's say, I think we will agree on some common program with Green Building Council in Latvia, Lithuania, Estonia, that they will develop those kind of trainings. And they're doing it. They're working in that area. But we will add some, let's say, we can add something more to that training, to the training program. So it's through the Green Building Council and through the just universities. So this is how we think, and this is what we are planning to develop with those organizations.
Yeah, like one course could be, which we've done at other green building councils for Italy, for example, is we have the Italian group will teach how to use LEED, how to use BREEAM, how to do these sources. It's completely done by the Green Building Council. And then you have people come in to teach the special pieces of it that need to be done, how to simulate for these systems. Or then you have a life cycle expert come in, how to do life cycle analysis. And then you have the group of
what to do, but how to do it.
How to do it, because that's the thing. I think you have the systems and you're like, great, so I have to do all these things. I don't know how, you know, and then you just have different companies. It's our company, it's other companies, it could be anybody that comes in and teach it. But I think what we're doing now is we've partnered with someone locally. That's the first step, right? Then we educate them on how to do it. Then they spread it through the educational market.
And of course, there are third level.
Yeah.
Individual company level.
Yeah.
Just with your customer, you of course also should be educated.
Yeah.
So, did I answer your question?
Yes.
Okay. I will raise one question.
Okay.
I spoke with one property development company, and they told me, okay, what is showing and your ideas is very good, but who can do that in Lithuania?
Right.
So we should be clear that not too much expert on this things, not yet in Lithuania. It's just beginning. There are some companies which, let's say, leading in that area, but it's probably a message for property developers. It's possible somehow partnership.
Yeah. So we have something, yeah.
To work together in order to reach good results. In order, because that property developers called the grant, they told me, I don't want that I will be first project. Or for example, Quadrum. Yeah, Quadrum Management Project. So, we can, let's say, somehow to cooperate with IS service business department and to merge, let's say, efforts, knowledge in order the result will be really good, even from the beginning. And then those companies which will participate in that will learn more from the practice.
Yeah, it's called project-based training. So say you have a bid that comes here and it's for a BREEAM building. And you don't know how to do BREEAM, but you certainly have a bunch of mechanical engineers. You can come to our company and we do what's called project-based training. So we can do portions of the project for you, and then we will come to your office and teach you how to complete the project yourself. So next time you will see what was done, and we're part of your team, so you can bill for our hours to your clients as well. And then the next time you've learned through doing, basically. So that's one option of how to do it. Instead of paying for training separately, you partner with us. And that's what we do for a lot of clients. We may come in as either a hidden partner or a public partner if that helps you out, and do the portion of the project with you.
So what I would like to say that we're ready to support beginning.
Yeah.
From long-term perspective, we're ready to cooperate with organization, with academic organization, with a specific green organization in order to implement long-term, let's say, education of our countries. But also we can start immediately with professional support. We can start immediately with some companies, with some projects.
Or if you think you got it right and you're not sure, you can send it to us and we do a professional review on your model to say, okay, it looks right, or it doesn't, here's what we changed on it, and this is where you made the mistakes, perhaps in your system setup or something. So that's a lot of the things that we do when companies are starting.
And maybe you can tell your, let's say, some experience partnership with universities. Or what type of partnership,
So yeah, with the universities, we basically...
Or with green building council, some practice.
Yeah. Well, I mean, it's up to, I don't want to talk too much about partnerships because that's up to you to do that. So I don't want to say whatever we do in
what we should do,
yeah, what different markets you do different things, but some markets we would have like, we give the software, they use it, and we allow the instructors, for example, to attend our courses for free online. So the instructors can become trained in our software for free as long as a paying customer is attending the online training. So that's one option that they have. And then if there's events or something, and like say life cycle analysis, one of the instructors wants to come to the UK and go to a group training, we'll give it to you at cost, those types of things. So it'll be much cheaper and much easier for you to do that and get up to speed very quickly. But again, everything is negotiable with these things. If you go on our website and you look at the standard prices, everything is negotiable in every market. So you talk to him about it. Don't just look online and say, oh, this is the price, right? That's not necessarily true. Also for students, if you look at the student price, that's for our #1 markets. So don't worry about that. Talk to him, and we do special cases for emerging markets. We don't expect you to pay the same as
so
the establishments.
We are open for all kinds of operations. And green analysis ideas in our Baltic countries. Some questions from online?
Yeah, he's talking about the heat pumps. Yes, you can absolutely do both water source heat pumps and air source heat pumps and do comparisons between the two. Basically, you would build, the question is there a portion of IES that's dedicated to heat pumps? And yeah, absolutely. We have both extensive water side and air side systems, so you can model both. You would basically build two HVAC systems and you could compare them. So it's easy enough.
It looks tired.
Everybody looks tired. Yeah.
We may not use water.
I know. It's fun. All right. And also, again,
Yeah,
my card is up here. If you have questions when you get back, please email me technical questions. It's fine. You want more technical demo? We can do that we can do the full HVAC demo. We can do whatever.
If
So
someone would like to have some short
Yep.
discussions, so just
Yep.
we can just
We'll be
now
here.
after seminar immediately
Yep.
do that. Okay. And there are some brochures.
yeah, there's one that talks about the tools, and then there's some case studies.
Okay, thank you very much.
All right, thank you. All right, thank you online. Please email us directly if you have any other questions, and I will put up our email address here in the window. So this is my email address. And you can contact me personally if you need more information, or you can also contact Ernestus. And he was the one listed on the registration sign-up, so you can find that easily. So let me just get his email, and I will send that to you. One moment, and I'll put it in the chat window, but you'll also receive a bit of detail after that about that. So, and he will be in charge of all the pricing. So if you have any pricing related questions, you can ask him. So I'll just copy it for you. Okay, the email address is in the chat window below. So make sure you just copy those because I will end the session very soon. All right, thank you for attending, and everyone have a good afternoon.